Okay, we're on page 106, and we're dealing with rational numbers and multiplying. And if you look on the top of page 107, what are the two rules? So there are two rules for multiplying these numbers. Hold on. Raise your hand and read it for me. Benton, read that first sentence, please. All right, the product of two, and we're talking about rational numbers, two numbers with the same sign is going to yield a positive product. Okay, and I want to highlight some things here. The product of two numbers with the same sign is positive. This is a good sentence to break down if we could. Grammatically, what is positive according to this sentence? What's going to be positive? Yeah, what exactly? The product is going to be positive. Good, yeah. The product of two numbers with the same sign, and specifically the product is going to be positive. Okay, what's product referring to? What operation is product referring to? Multiplication. How many numbers are we dealing with? Two numbers with what kind of signs? Same, and that gives me what kind of product? Positive. Okay, those are the main ideas. So if you have two numbers being multiplied with the same signs, whether they both be positives or negatives, what kind of product are you going to get? Positive. Okay, two numbers with the same sign multiplied together give me a positive number. Guys good on that? Okay, what's the second rule? Someone read me the second sentence of that little box there. James, can you read that second sentence? The product of two numbers with, in this case, different signs is going to give me negative. Okay, what's the operation? Multiplication, because we're talking about product. How many numbers? Two of them. What kind of signs? Different. Give me what kind of product? Negative. Okay, do you notice how there are two rules for multiplication and two rules for addition? Ready? Are they the same? No. And are you going to be dealing with multiplication today? Yes. Are you going to be dealing with addition today? Yes. So you can't mix them up. We're talking about multiplication of two numbers with same signs or different signs and what they're going to yield. So if I have a positive times a negative, what's that going to get me? Negative. If I have a negative times a positive, that's going to get me a negative. They have opposite signs or different signs are going to be negative. You guys got that?
Yes, sir.
Okay. Two numbers. Look at number, on your homework you're going to do on page 109, you're going to do a problem like number 26. So if you look at that one, how many numbers are being multiplied?
3.
Uh-oh. Do you have to come up with new rules? No. We're going to apply that rule.
Like there's 3, so like multiply these two together, and get that answer, and then I'm going 2 down, and do those two together.
Gotcha. Thank you. And we'll talk about that more to make sure we get it. Good. All right, example 1. Let's see how we actually apply it. Example 1a. We're multiplying negative 9.8 and 4. Negative 9.8 and 4. Okay. The tough thing about multiplying decimals and fractions is sometimes we work these out. We get an answer, and we're like, oh, okay, I know it's positive or I know it's negative. That's not the problem. The problem is, does my answer even make sense? And I'm like, I don't know. It's decimals. I don't even understand them. Okay, look at this problem right here real quick. I don't know what this answer is right away, but what does negative 10 roughly round to? Negative 9.8 rounds to negative 10. What's negative 10 times 4? Okay, in my head, you don't have to write this, but in my head I'm thinking negative 40. That's a good number to get around. If my product is close to that, my answer is called reasonable. If it's not close to that, something went wrong, okay? So multiplying decimals with whole numbers or integers, I usually put the one with the most digits up top and the one on the bottom with the least amount, and one's negative, one's positive. So automatically, the rule is my answer is going to be what? Positive or negative? Negative. Why? Because they have different signs. That's the whole point of those two little sentences up there. Okay, what's 8 times 4? Everybody.
32.
Good. What's 9 times 4?
36.
Plus 3? All right, and then I have to think, where does that decimal point go?
Right between the
9 and the 2. There's one decimal place here, so I move it once to the left, and I get negative 39.2. Now, that's my answer. Look at my estimate. Are we pretty close?
Yeah.
Okay, I'm not going to say your estimate guarantees your answer, but at least I can say that's reasonable, okay? If I got something way off of that, it's unreasonable, and I should check what happened that maybe caused that to happen. B, negative 3/4 times negative 2/3. Negative 3/4 times negative 2/3. All right, ready? Here's the question. Positive or negative now? What? How'd you know that? Same signs, two numbers being multiplied, got to give me a positive. And I put the positive for emphasis, like it's got to be positive. All right, and you guys remember when multiplying fractions, you just multiply the numerators and then the denominators, right? But isn't there a way to make those numbers maybe a little bit easier to use or deal with? What's that useful tool that we have to eliminate or break down or cross something out? Yes, ma'am?
You like, I don't know what the rules called back.
Canceling. Very good.
Great, canceling.
So what can I cancel in this one?
The 3 can be 1 and 1.
So 3 over 3 is 1 over 1 or 1.
The 4 and the 2 can be 1 and 2.
By the way, if you write that too small, it could be a little tricky. I've seen some of your writing. I'm like, man, that 1, I can see it, but it's tough. It's tough. Or it's a little bit sloppy. Is that a 1 or is that a squiggle? And hopefully you know what it is, but at the same time, you need to communicate that to others. What's 1 times 1? What's 2 times 1? So what's my answer here? 1/2 positive. And you don't have to write the positive with it, but you can. It's positive 1/2. Okay. A negative times a negative equals a positive. All right, example 2. What's the difference between example 2 and this last example with example 1? There's one big difference. Excuse me. Okay? What else? I think it's 5, 6, actually. Anything else? A variable. Do they tell me what that variable equals? Yes, it equals 2. All right. So you're going to evaluate. I want to find the value of this. Well, Mr. It's right there. I want to find the simplified value of it. So what does A equal? 2. What is 5, 6 squared? What does that mean with multiplication? Yes, sir? 5, 6 times 5, 6. That's what it means with multiplication. In fact, how many numbers are being multiplied here? 3. What property says I could do it in any order? Commutative property. So you can apply the commutative property here. That's fine. We'll just do these two first and then with the 2. What is 5, 6 times 5, 6? Anyone know? 25 over 36. And then that's going to be multiplied by 2 over 1. And to make life easier, what can I do?
Just cancel it.
Yeah, cancel what in this case?
The 2 over
Yeah, what's 2 over 36 also known as, in a simplified form? 1/18.
yeah. But like, can't you, wouldn't, so when you multiply the fraction times 2, wouldn't you have to divide it by 2 because then it's an even number? But
I think I understand what you're saying, and let me give you something that might answer that, and if not, ask me again. Let's go with here. What's 1 times 25? 25. What is 1 times 18? Okay, let's say I did this problem and I just did 2 over 1 times 25 over 36. Wouldn't I have gotten 50 over 36?
yeah.
Right? I would have gotten 50 over 36. Is 50 over 36 the same as 25 eighteenths?
Yeah.
So what's nice about canceling is if you do it before you multiply, which is easier, then your product is going to be as simple as it can be. Okay? Like, can I divide these by anything else anymore?
No.
No, not evenly. And here's something new. That's my answer.
Yay!
Done. Celebration time. Where you're like, what just happened here? Okay. Do you guys remember what we used to do with these?
You guys turn it into a mixed number.
Okay, we changed it to a mixed number because right now it is called an
Improper fraction.
improper fraction. You can divide it and get 1 and 7/18. You can leave it as an improper fraction that's simplified lowest terms. Listen carefully though. Let's say you had 5 over 1. So that's improper, but can't that turn automatically into an integer? So you have to write it as that integer. But this one would be a mixed number.
What if
You can leave it like that.
6 over 2?
What do you
You
think?
can easily turn that into...
There you go. That's your answer.
Big number.
But like you can easily...
356 over 2.
No, it's not
Well, do you see how
I
you can divide both those by 2?
Let's start on the homework.
Hopefully you won't get too many of those.
Okay, that makes more sense now. I just answered my question.
Did it answer your question that last one, or if not, ask me
I
again?
mean, it
I'm
wasn't,
curious.
but I answered it because what I was saying was
All right, listen up, guys. I have a good question. Yeah.
When I was multiplying it by 2, I was multiplying the numerator and the denominator, which is multiplying it by 2 is multiplying.
Good. Yeah, that's it. So, like, if it was 2 over 2, that'd be 1, which wouldn't change that. It leave you with 25/36, which would not be the answer. Good. I'm glad you understood what you did. Okay, example 3. Wow, I'm having the hardest time getting that little button there. Example number 3. What's the difference between this and the last 2?
It's 3 numbers. Variables.
Yeah, you got some variables that you have to multiply now. Yeah, they don't give you what the variables equal. They just give you the A and B on A.
Oh, that confuses me so much.
All right, so let's nail it down here. So 2b times negative 3a. Okay, 2b times negative 3a. Okay, do I know what a is? Nope. Do I know what b is? Nope. But can I make this simpler? Yes. First of all, let me ask this question. Is this product going to be positive or negative? Go!
Negative.
Okay, it's got to be negative. It's got to be negative. Because what's a positive times a negative? Negative. So we have that. We have that down. Now what you're going to do is you're going to realize this. Aren't you multiplying 2 times b and then 3 times a? And then those two are being multiplied by each other. So does it matter the order that you're multiplying these 4 little numbers?
Absolutely not.
So you're going to multiply the numbers first. What's 2 times 3? 6. Yeah, and it would be negative 6, but thankfully it's already there. What's b times a? It's either ab or ba. Both of these are the same answer. So we'll go with this one just for... Okay, good question. So here, can I rewrite this as 2 times b? So is this 2 times b? Okay, and then here it's negative 3 times a.
Are you redistributing the distributive property?
You're doing the commutative and associative at the same time. Or you could do it back to back. Ready, guys? Are these two being multiplied?
Wow.
These two being multiplied? Okay, right now do you see the associations? Okay, watch what I'm going to do and tell me which operation I use. Ready? Which property did I use here technically when I moved the order around? Order. I hear all the properties except the one I want. Commutative. When I change the order, what's that? What's that property? Commutative. But then I grouped differently, so you can also say associative. But regardless, do you guys see how I did that from here to here? So what's 2 times negative 3?
6. Negative 6.
And then what's b times a? AB or BA. So you guys kind of get that?
I get that. It's different from the last lesson when you can't combine.
Good question. Oh, thank you, Ben. Actually, this is good. What's this lesson titled? Multiplying rational numbers. Thank you, guys. Thank you, Swivl. You got that. What was 2-5? Do you guys remember? Adding and subtracting. So, remember how I brought up, how many rules do you have for adding rational numbers? How many rules do you have for multiplying rational numbers? Are they the same? No. The two will never meet. No, they will meet, but you don't just mix the rules around and say, oh, 2 negatives equals a negative. That's when you're adding. 2 positives added together.
That's a fact. Difference and subtract. That's a fact.
Speaking of multiplying and adding at the same time, YouTube it, put adding and subtracting, multiplying, you'll find out whatever videos you want. Yeah, you might even find me. Okay, anyway. 3x times negative 3y plus... You might have to search me for a long time to find it. That's okay. It's for you guys. It's for you guys. Pop up now. By the way, yeah, that channel is dedicated to you guys. So it's there for you if you want to look back at the lesson. What was he talking about? It's right there, hopefully. Okay, listen carefully. Am I multiplying in this problem?
Yes.
Am I also doing something else?
Yes.
What is it? Adding. So we're mixing the two together, which is going to happen. You're going to get used to it. Order of operations was, I think, the 3rd or 4th lesson in your book. It was the 4th lesson in the 7th grade book. Why do you think we put that at the beginning of your books? Very important. Very, very important. Order of operations says to do what first? What are you supposed to do here first? Multiply. Yeah, parentheses, you're like, can I make that simpler? Nope, nope, nope. So then you go to multiply. I'm going to multiply these two and then these two. So first take these two. Positive or negative?
Negative.
Negative, because a positive times a negative, negative. All right, you're going to multiply the numbers together. What's 3 times 3? 9. What's x times y? That's what you get with the first multiplication. You guys see that?
Yes.
Okay, good. Then you have this plus. What's a negative times a negative? Positive. You already know it's going to be positive. What's 6 times 2? What's x times y? Ta-da! That is my...
No.
You can add those.
Wait, did I... Whoa. You can add these two together? Why?
Because they're like terms.
Okay, I heard many of you, which were correct, like terms. What's the definition of like terms? I need to know that definition. Because, yeah, they're like terms, but why? X and Y. No, just like terms. Sorry, I'm confusing myself. Hayes?
It's like 2, what do you call them?
Terms?
Yeah, terms that numbers 4 variables and they have the same exponents, so you can add them.
Okay, these two terms have the same variables with the same exponents. All right, what are the exponents of x and y here? 1 and 1, right? They're not written, but they're there. What are the exponents of x and y here? 1 and 1. These two have the same variables with the same exponents, so you can combine them by adding these coefficients. What's negative 9 plus 12? So that's asking, what's a negative plus a positive? It depends. Which one's bigger? Absolute value. So it's going to be positive. We already know that. So what's 12 minus 9? 3. And then you keep the variables and their exponents the same. And I do this for emphasis. You don't have to write a positive. It's 3xy.
Yeah.
You guys see that?
Yes.
Okay, because you're going to do this many times over. Many times. Many times. Okay. So you got that? All right. All right. We have our 15th property of the year. Bottom of page 107. What's that property? 15.
Property of -1.
Multiplicative property, I'll put that, of -1. Someone read that for me out loud, and then someone else tell me what that means. Okay, go ahead, Benson, read it out loud.
The product of any number in -1 is its additive inverse. -1a equals -a, and -1 equals -a.
Yeah, so on that bottom line, you'd say -1 times a equals -a, and a times -1 equals -a. Okay, how many of you kind of see that? Like, a negative times a number is going to be, okay. Multiplicative property of -1. Some of you are like, I don't see it. Okay, ready? Here's how you can simplify it. A times -1 is going to give me what? Negative A. Okay, somebody read for me that first sentence again, because this is where it gets confused. Like, I get that. I don't get what they're saying at the first line of that box. Kendall, can you read that for me again, the top product?
The product of any number and -1 is its additive inverse.
There's the confusing. Wait, additive inverse? What's that? What's an additive inverse? Ellie?
Like 1 and -1, they equal.
What's another name for additive inverse? You get what's another name to say 1 and -1? Opposite. Okay, ready? Here it goes. Any number times -1 is its additive inverse. Which aren't these opposites?
Yes.
That's what they're saying. I know, it's close. Why are we clapping again? Okay, yeah, just clap. Okay. What I want you guys to get what I really want you to get here is that any number times -1 is the additive inverse, which is the opposite of the original number. So, give me a negative number. Negative number, yep.
-4.
Okay, ready? -4 is going to be A. What's -4 times -1? It's 4. Ready? -4 and +4 are two additive inverses or opposites, okay? So when you multiply a number by -1, you get its additive inverse. That's what we're trying to say. That's very important. Okay. Last example, example number 4. Turn the page to the final problem of the example. Whoa. You're anxious to get this done, right? Okay. Example number 4. Yeah, whoa. Oh, sorry, guys. Wow.
We don't do it anymore.
I don't want to.
Sorry about that mixed number there. Okay. I actually took a little bit longer with the other class to go over this one. I want to make it quick for you guys. Remember how the rules we were talking about dealt with how many numbers? 2 numbers. Two numbers being multiplied, right? 2 numbers being multiplied. How many numbers are being multiplied here?
1, 2, 3, 4.
5 of them. What's the rule with 5? I actually don't know what the rule is with 5. Or 6. Or
You just
4.
keep multiplying them 2 by 2, like the animals on the ark.
Okay, thank you. Yeah, one way to do it is simple like this, guys. Listen up. All right, I just want to find the sign of my product. I don't want to, not yet with the product, but the sign. Ready, guys? Everyone follow me. Please follow me.
Right.
A negative times a negative
Positive.
times a positive
Positive.
times positive times a positive times a negative. So my answer has to be negative.
Negative.
That means I am done with the positives and negatives. I don't even have to think about them anymore. And I'll show you what to do with the next. I'll show you how to do a shortcut with that. Okay, I'm just going to use the numbers. What do I do with the mixed numbers?
You turn them into fractions.
Turn them into improper fractions. That'll help out. Oh, 17, excuse me. Yeah, 15, 17. Okay. And then I'll make this. Yeah, and then even this one, you don't even have to change it. I'll tell you what to do with that. Okay, I just changed everything to an improper fraction or fraction because I like doing this before I multiply it. What's that? This. What do I like doing?
Oh, cancel it.
Cancel. Yes. Okay, look how it works. I love canceling. Are all 5 of these numbers being multiplied? Yes. And you know what? To be honest, I don't even need that anymore. And I don't need that anymore because what did I already determine about the sign? It's negative. So I'm done with that 5th number. 4 numbers. 1 and 1. I could go all the way across there. I'll go 3, and 3 is 1 over 1. Anything else I could do? I don't see anything. I have a 13, 17, 5, and that's it. What's 13 times 17? That's the hardest part about this problem.
241.
Sorry. 221. Thank you. So 221 over 5. Can you divide both of these numbers by the same number anymore and get an even answer? So guess what? That's going to be your answer. Okay, what do they give you? Yeah, negative 44 1/5 is also the answer, but so is this. That's your answer. You're done. Okay, now listen to me carefully. I'm going to give you guys a problem that wasn't in that. Wow. You see how I'm like hitting it, but it's not registering. Okay, ready? What is a negative times a negative times a negative times a positive times a positive times a negative times a positive times a, sorry for that last one, times a negative times a negative times a positive times a positive times a positive times a positive, and for good measure times a negative.
Negative.
All right, I need, how many of you say it's negative? Negative. Okay, about a quarter of you. How many say positive? About.
Wait, can I like give a second?
I would look at it.
Positive and then negative and then negative and then negative and then positive and then
This negative.
positive and then negative and then
Negative. Has to be negative.
Yes, I knew it was. I beat all of you.
Okay, ready? Here's how you work it out.
positive and positive.
Some of you are doing, negative times negative is a positive times negative, 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 positive. Okay, and you work it out. Here's how you do it. How many negative factors are there here? Is that an odd or even number? Has to be negative. Has to be negative.
Margo figured it out. She's not here. It has to be.
There you go. So Margo, using that understanding, because you seem to understand it, I have, ready? Listen to me carefully, guys. You listen to me because she could be right, she could be wrong. We want to make sure we get it. Ready? I have a multiplication problem with 100 factors. Okay? 51 of them are positive and 49 of them are negative. Margo, this young lady right here, Margo. So, sorry, 51 positive, 49 negative, I said?
Yeah.
It seems really simple.
What is it? So 49 negative, 51 positive.
Wait, you have to go through.
Wait, move your head really quick.
How about this? Let me write it down so you guys. 49 negatives and 51 positives. Which one? Go. Give it. It's got to be negative because how many are there that are negative? It's an odd number. Boom, done.
I knew that was
Good.
right.
I know, it was tough. Swivel's looking.
Does a positive matter?
Positives do not affect the sign. Good question. If I had 1 million positives times 1 negative, it's negative. You're done.
If you have
Negative.
1 million positives times 2 negatives, it'd be positive.
Very good. Yes, very good.
Wait, so
Yes, ma'am. Yes. Okay. Last problem is this type. We didn't go over this, which I think is not. I'm just showing you one problem you're going to have to do is like this. This is called a matrix. The matrix. And I'm going to edit that so Swivl can get it in the real matrix. Okay. You know what matrix actually means? The stuff something is in. So you're in the matrix right now. It's the matrix of air. Oh, whoa. Okay, yeah. Okay, we're done. Okay, when you get a problem like this, these numbers are in the matrix, and this number right here is multiplying each one of these numbers. What do you think the products are going to be? Well, what's m times a? What's m times b? M times c. You're just multiplying 6 times.
Because I like wrote all the answer, I'd have to write all that. Like I'd write M A M B M C M D M B N.
But what they're going to give you is actually numbers. Number, so you just multiply those out. That product of those two multiplied out goes right here. These two multiply, it goes here. You're multiplying. When you have this number next to this.
You just leave them in the bracket. Okay,
We'll talk more about the matrices as we get through this chapter. Okay, ready? Your homework is 18 to 48.
Odd.
The end. Whoa. How dare you? Actually, it was 48. Wow. I don't want to trick you. Yep.
Wait, is it?
Get working. Yes. 66 to 68.
Even. Who needs a piece of paper? Yes. They don't need anything. Okay, Mom? I just told you I know
There's more?
14 to 48. Even.
Look at that. Just took some problems away. Okay, how many of you think that's a lot of problems? Raise your hand. How many think 18 to 40 is a lot? Okay, so why don't you act like it? If you had a lot of problems, you would just sit there and waste this time, or would you? I hope not. Be wise. I'll tell you this. Let me give you some encouragement. 18 to 35, a lot of them are straightforward. The ones that have decimals, that might take you a little bit of time. After you get through that section, it shouldn't be that hard. Because you basically have just 1 or 2 more decimal problems.
Is it the 25th?
Today's the 25th.
Wait, it doesn't start against the
Why did I have some medium?
Sorry, I wrote the wrong thing, Wyatt. Bye, so.